First is a talk. It's called Making Cozmo See. And Cozmo is a robot. I'm told it's the best-selling toy robot of 2016. And one of the things that it does is interact with its owners using a visual system. So now Andrew Stein is going to come up and tell us about that.
All right. So I'm Andrew. I'm here from Anki, and I'm going to tell you a little bit about our robot Cozmo. So first, I'm just curious how many people here have actually heard of Anki at all? Okay, great. That's a big number. So we're a small robotics and AI company up in San Francisco, and we're focused right now on entertainment. And so our two products are Overdrive, which is a toy car racing game, and Cozmo, which I'll talk about here. So same question, who here has heard of Cozmo? Also not bad. And does anyone have a Cozmo? I know you do. All right, great. So for those of you who may not be aware, so Cozmo is an app-driven autonomous character robot. So it's like taking a character from a movie, from the movie screen and making him real. We launched him last fall, and as indicated, he sold very well last fall. We sold out, and it was a very popular premium toy on Amazon. Price point's $179. And as a particular interest maybe to this crowd is that he also comes with a full-featured software development kit in addition to the app that you play with him with. So that's also pretty compelling, and I don't have time to get into it here, but there's a lot more interesting stuff coming in on the education front with the SDK. So Cozmo is actually already being used at Georgia Tech and Carnegie Mellon in the robotics programming classes. So there's a lot of pretty interesting stuff to be done with the SDK as well. So the primary goal of the whole product is really just to bring Cozmo to life, to make him seem like a little aware being. He's not going to vacuum your floors. He's not going to clean your kitchen. It's not about utility. This robot is just about entertainment and fun. And so really it's all about giving him personality, and that personality is achieved through animation. So he's animated the same way that characters are on screen. We have a team of animators who develop his backstory, his character. They animate in Maya the same way they would for a CG movie, but we render those keyframes from Maya directly onto a physical robot. So that allows us to use that power of personality and storytelling that we get from the creatives at the company and deploy them in a physical system. And of course, in addition to performing, he's also interactive. So that's, of course, where vision comes in, how to make him aware of his surroundings. So just to give you a little bit of an idea what kind of personality I mean. So most of these I think are prototype robots. So they aren't all painted up and as pretty. These are some early animations, but I thought I would just show a few examples. Oh, this one has sound. Cool. So that was him just wiggling that he's happy. These are just little tidbits to give you an idea. That was him rolling his eyes when he gets annoyed. The bottom right, he's playing a game. He's going to do a little fake-out maneuver. So the goal here, you can see, is to keep him a little more alive than typical robotic movement. This is him getting mad. So the cube blowing up was just a happy coincidence, but that was him getting mad when he lost a game. So this is what it's about, is sort of bringing him to life more than you might typically see with another consumer robot. I won't name names. So under the hood, we're at the Embedded Vision Summit. So under the hood, let me tell you very briefly about some of the hardware he has. So inside, he's got four mechanical degrees of freedom. He can move his head, his lift, and his wheels. He has a speaker, which you heard. He has an animated OLED face, which you saw. His primary sensor, and of most interest here, is his camera, which is at VGA resolution, running at 15 frames a second. He has a low cliff sensor on the bottom to help keep him from driving off of your table, although he's pretty robust even if he does. And then he has encoders and an IMU to do odometry. His battery life is about 1 to 2 hours, which is pretty good for a toy doing the amount of stuff that he does. And his processing is divided over 3 different processors on board. So he has one focused on comms, one focused on very low-level hardware control, and then one which we call the supervisor, which is an M4 class processor, which does most of the heavy lifting. Okay, so I told you he's animated by a bunch of storytelling animators. So you might imagine, all right, there's a script, there's an animation library, which is driven by that script, and Cozmo performs for somebody watching him. That would be a nice linear flow. And of course, this is not at all how it works. That would make our lives far too easy. What we really have is a person watching Cozmo. That person is generally like a 6 to 10-year-old kid, so they're constantly reaching and grabbing for Cozmo and moving him around. And what we have under the hood at a very high level are a bunch of what we call behaviors to drive the different things that he can do. And those indeed impact what animations get played, which are generally open loop, but they also impact controlled movements, which are closed loop, and path planning, which he has to do to drive around obstacles. Those, of course, control the robot. He has sensors, like I talked about, the camera and the cliff sensor, taking in data. All that's fed into a world state that we're keeping up with. Reaction triggers for if he gets picked up or drives up to a cliff and something unexpected happens. An emotion state, which we actually model to drive the personality engine. That affects how he might drive. There's game logic running on top of all this world state to impact which behaviors get chosen, et cetera. So we have a pretty web-like architecture at a high level of what's going on here. So by now it's clear that Cozmo is very far from being a static surveillance camera. He moves around, so we have to deal with things like motion blur. We don't want him driving off cliffs. We need to have some sort of localization information because odometry is, of course, not reliable, not only due to drift, but the fact that we have treads, which look cool but are miserable for robotics. Very hard to model treads and how they interact with different surfaces. So vision gives us a leg up there as well. For anybody who's worked in robotics, the quote-unquote robot kidnapping problem from the literature is very real when you're dealing with 6-year-olds. So this is a real thing. He's constantly getting picked up and moved around, and we have to deal with that all the time. So how do we maintain our world state internally and broadcast that out to the other layers of the system for the behaviors, et cetera, to know when things are awry? And finally, Cozmo is interactive. For him to seem alive, we want him to interact with people, see their faces. He needs to be able to see those little cubes he plays with as his toys, et cetera. So I'm going to talk very briefly about the vision capabilities. I'm not going to go into details of how we're doing anything. I'm more just going to describe the kinds of challenges that we faced and things that he does. So on the list of requirements here is that, as I said, he has to be able to detect his cubes and track them, recognize which ones they are. He needs to be able to detect and track and recognize faces as well. He responds to some motion, so he can pounce on your fingers if you wave them in front of him. I'll talk a little bit more later about how we did enrollment for face recognition in an environment where people have no idea what face enrollment even means. Again, a kid doesn't care how this works. We have to be able to estimate the 3D poses of our objects, whether those be faces or cubes, so that he can remember where they are and drive up to them and interact with them. We're maintaining a map of the world even when he gets picked up. We've got a moving cell phone camera, so of course we have rolling shutter, so we have to deal with rolling shutter correction all the time. And this is a lot of different things for one little toy robot to do, so we also have to have a system on top of it to flexibly schedule what he needs to be doing depending on what behavior is running and how much computation we have available at any point. So on the faces, I'm not going to go into this in great detail because I think most people here are fairly aware of face detection. This does face detection like anyone would imagine we do face detection. We also detect landmarks in the face so that we can do estimates of expression, so we can get estimates of people's emotions. And we can enroll up to 10 people, so he'll remember you across play sessions and remember your name and can actually say your name. And those are enrolled via a little activity we have in the app called Meet Cozmo. And then part of the point of all this is so that, again, to be engaged with the product, it's much more compelling if he seems to know you're there and make eye contact with you. So we need to remember where you are in 3D and be able to look back at you in the middle of activities. So it's not just a robot running around on your table. You're engaged with him because he knows you're there, and that makes a huge difference for the character. He can also do cat and dog face detection. Again, it's just to make him seem more aware. So if he sees a cat and sneezes, it's kind of funny. And again, makes him seem more alive and aware and have more personality than he would otherwise. And then the big one where I've spent a lot of time is on detecting and recognizing his cubes in his charger. And all the vision people in the world recognize very quickly, although general people had never figured this out, which is always shocking to me. This is, of course, done by the markers on the sides of the cubes. No one ever seems to realize that. So he has these markers that he can recognize and, of course, use their known size to estimate the 3D pose of the cubes as well. And we give you another set of 16 of them that he knows about, which you can use in the SDK to define your own objects, so that you can define your own custom obstacles and things for him to drive around. And that brings me to a little bit of an aside, but something I'll talk about a little bit more later as well. From a vision standpoint, we could have just slapped QR codes on the sides of the cubes and called it a day. And in fact, that is where we started, is a QR code-like system. Use the corners of those squares and done pose estimation, all good. But we also have a product we're trying to sell with a design vision, and the designers don't like QR codes because they don't look cool enough. So they wanted more aesthetically pleasing, and we can argue whether or not those are more aesthetically pleasing, but they wanted more aesthetically pleasing markers. And so how to build a system which was more flexible and allowed an artist in the loop to design those markers, as opposed to me as an engineer just slapping some squares down. And then furthermore, they wanted rounded corners. So small thing, but everyone knows rounded corners look better than square ones. But of course, for pose estimation, and very accurate pose estimation, I want very accurate corner detection on my markers. And you can see I don't have a lot of sharp corners. So we had to adapt the algorithm to use the implied corners of the lines around the square. And again, minor thing, totally solvable, but it was an extra step we had to do to meet design in the middle to make the product that they wanted to make. Another thing we wanted to do for things that don't have markers on them, I'm running a Cortex M4. You're not going to be too shocked to learn I don't have a whole lot of deep learning going on. So I can't recognize everything in the world and know where it is. So we wanted Cozmo to, again, seem more alive and be able to interact with just general stuff. And to interact with it, he needs to know where it is. And I also don't have a RGB camera, so I have no depth information. So here we're doing another sort of standard trick of using a homography and mapping our image onto a ground plane. So I have a synthetic image in front of showing the world in front of Cozmo. And so you'll see when I move, I think it's a cell phone, into his field of view, he sees it and can map it into his 3D world at the top and know where it is in front of him. Now, he has no idea this is a cell phone, but he knows there's something there, and he can actually drive up to it and sort of look interested in it. And again, this is to make him seem more like a little living character and more interactive with his environment in as inexpensive way as we could. OK, so system architecture-wise, how do we lay all this stuff out? What I haven't told you so far, although I mentioned he's app-driven, is that we have offloaded all of the vision and really all the hard AI stuff onto your phone. So Cozmo is a Wi-Fi access point. Your phone joins that access point, and we offload the computation onto the phone by streaming the images over Wi-Fi onto the device. We initially started by building a lot of this stuff right onto the robot, and we got pretty far with it, but eventually determined that the cost, and I mean that in two ways, the cost was too high of doing it. One is that development is very slow for an embedded device. It's hard to bring on lots of people into a project who aren't familiar with developing an embedded environment with the tools that we had, and being able to develop on iOS and Android with existing tool chains is much quicker. And the bigger one is the hardware cost. So I learned very quickly about the difference between COGS and BOM, and this was my first hardware product. And as many people here well know, even seemingly very inexpensive parts add up very quickly. So $179 to produce everything that Cozmo does with all his degrees of freedom in the packaging and the cubes, et cetera, we had to squeeze a lot out of very little. So how does it work? Cozmo has on board, as I mentioned, his low-level hardware drivers, the low-level controllers, and the communications. And then on the phone, we have an app which internally has what we call the robotics engine. That's where the vision runs, where AI runs. Sitting on top of that is a layer in Unity, so in C#, which runs the UI and all the game logic. And those two communicate over Wi-Fi. And additionally, we can communicate between the engine and a Python SDK, which runs in your laptop. And all of these connection arrows I've drawn here are something we call CLAD. You can just think of it as protobufs. That does some more things for us than protobufs. It's a custom cross-platform messaging API. And that's been great because it means that we can use exactly the same approach, whether we're talking over Wi-Fi, over USB, between a C++ engine and Unity. It's all language agnostic, everything, all generated code. And that's been a huge boon for keeping interfaces clean. So this, of course, doesn't come without complications. By taking the processing of the images off the device where we're processing them, we had to pay some prices, pay a price for that. And one of those is in animation. So animations can't play instantaneously. We have to buffer them because we're streaming audio and video, and we don't want choppiness. Audio is particularly terrible if you have a little device that's skipping audio. Think about a bad Skype call. And so we have to buffer things. Now we can't play everything instantaneously. How to deal with that was a big part of the puzzle. One non-obvious one, perhaps, is for face enrollment in the Meet Cozmo activity that I mentioned before. So we have users who have no idea what face recognition is, how computer vision works, or anything about face enrollment. And B, they're not looking at a device which allows them to see their own face or whether they're lined up with a box or anything, right? They're staring at Cozmo, who's looking at them with these, like, these nice blue animated eyes, but they have no visual feedback of what's going on or if it's succeeding. So how to design that activity to be robust to people moving around and how to enroll and give cues to people was a big part of that puzzle as well. In addition, we've got all these systems now talking over these messaging platforms or messaging interfaces. How to mirror state efficiently is an ongoing challenge. And then finally, latency, which is probably the most obvious one to people here. We've got fairly tight control loops around visual feedback for example, docking with his cubes that we're trying to control across a fairly latent and variably latent Wi-Fi link. And so being able to do that, being able to do that was also a challenge. So without going into too many more details, I thought maybe I would just show you some videos of what it looks like under the hood, since this is the kind of stuff you don't get to see in the app. OK, so this first video I'm going to show is me driving Cozmo around manually. And this is effectively our development environment. So this is Cozmo in his own brain. This is his field of view down here in the bottom left. You can ignore all this. This is just all of our status information. So what you're going to see is, hopefully, yes. So I'm going to drive Cozmo off his charger. Oh, and I should point out, oops. Okay. He knows his charger was there, so he instantiated that in his world. You can see he's creating a map, which is a quad tree-based map. He just looked up and saw a cube and instantiated that out in 3D. And now I'm turning him around and just letting him see other cubes. And you can see that the blue stuff that appears on the ground in front of the cubes before he actually looks up and sees the marker, that was that interesting stuff detection. So he knew there was something there, but he didn't know there was a cube yet because he hadn't seen the marker. Hopefully this will just pick up where I left off. Good. So now you're going to see I'm going to turn him around, drive him away from the cube, and then I'm going to drag a little green marker over here and tell him to drive to it. This is just to show you that he's going to do a little path planning around this obstacle and drive around it and get in position. And now what I'm going to do is pick him up. So you'll see his map is going to disappear because he has no idea where he is. He just knows he's been picked up. And as you can see, he's being waved around in the air. So he's totally lost. His map is garbage. And I'm going to put him down. He'll see his charger, whoops, but he doesn't yet know where he is until he turns and sees a cube from the previous map. So that's effectively loop closure, right? We have a bit of an engineered solution to loop closure because we have cubes we know about. But this is just to give you an idea. He is remembering a map and keeping up with all of this stuff. And I would argue for a toy, this is fairly advanced stuff at this price point. So this is to give you an idea of all the stuff we're doing under the hood from the robotics side as well. All right, and then I'll show you one more video. How am I doing in time? We're good. The next video, here we go. This one is going to be autonomous. So this is Cozmo running all his behaviors. This display here, which you probably can't read, it doesn't matter. Just to give you an idea, these are sort of different emotions he's got. These are different behaviors he's choosing between all the time. So that's the sort of behavior and personality engine, which I'm not going to talk about. But again, let's focus on Cozmo here, what he's seeing, and keep doing that. Here we go. So he's seeing me, and he's going to ask me for a cube. So you can see he's making eye contact. I'm going to hold up a cube. He's going to get excited about that. Now I'm going to hold it down in my hand, and he's going to come pick it up out of my hand. So he looks up at me first. You notice he makes eye contact. That's something known as referencing in psychology. It's a very deliberate thing we do. Same thing little kids do with you. So he's taken the cube out of my hand. He now knows it's in his lift. He's going to set it down on the ground. All right, and then I'm going to do another video here. Same idea. He's going to see the cube. He's going to request it, and I'm going to put it down on the ground. Now he's going to drive over to it, but look, on his way there, notice he sees a person. He's going to remember that person's there, and that becomes important because with this pickup, he's actually going to fail. So he actually makes a mistake. Whoop, didn't get quite lined up. He's going to get himself lined up and try again. But again, before he does that, he's going to make sure somebody's watching him, just like a kid does. So he looks back at Hans over there, makes eye contact, and then turns back and picks up the cube. And again, that little piece there makes an overwhelming difference in playtests. If you don't do that, it just seems like you're watching this robot do stuff. But as soon as it pulls you into the experience by looking at you, it makes a big difference. And then here he's decided on his own, for whatever reason, to go stack that cube on top of another cube he knew about. He checks to make sure everything worked, and he backs up, does a little celebration animation. So that's what it looks like on the inside. And then Jeff also wanted me to talk a little bit about building a product like this at scale. I don't know what people's experiences are in this room, so some of this may be obvious, some of it may not. The big thing for engineers to always remember with this kind of thing, again, this is a consumer product. We are not building something to be used in another product. It is we are building the whole thing at Anki. And the product is Cozmo. The product is not vision. So the vision on the inside is all well and good and neat, but the consumer absolutely doesn't care. They're deciding whether to buy Cozmo. They do not care about deep learning. They do not care about whether you're doing classical vision or what the latest and greatest algorithm is. And that means that we really have to let the product requirements drive the choices we make on the vision system and not the other way around. There are lots of cool technologies out there we might want to use, but if they're not in support of making Cozmo seem more alive, we don't do them because we don't have the time or resources to do that. That's not to say that the vision engineers and the rest of the engineering team don't have a lot of creative input into the product. But again, most of the decision making comes down from what are we trying to achieve with the product. One thing that is important to feed back up is realistic expectations. Again, people do not know anything about computer vision. It still shocks me. Even engineers in other disciplines have no idea what is and is not possible within vision. So being able to feed back to them what is either easier than they actually thought, which is sometimes surprising, or usually what is far harder than they thought is extremely important to keep things moving quickly and not go down crazy paths. I'm not going to spend a lot of time on this in the interest of time. Or actually, this one I will talk about. So again, calibration is probably not a novel topic to this audience. But as my first hardware product at this scale and price point, I was a little surprised to learn how variable cameras are at this price point, again, in manufacturing. So picking up cubes, whoop, that's pretty loud, sorry. Picking up cubes is a fairly precise maneuver, right? He's got to get these two little tiny fingers inside of these little slots that are just a couple millimeters wide. So we don't have a lot of slop there. And so we really need to know very precisely where those cubes are relative to the robot. And that can be a challenge in the face of lens placement on top of the camera package. And that amount of variability was enough that we actually have to calibrate every robot coming off the factory line. And so here I'll show what we call this test is called the playpen test. He just tested his cliff sensor. He's going to look up at looking around at these calibration targets around him. And right now he is calibrating his camera. His camera is calibrated. And now he's going to run over here and make sure that he can pick up a cube, which he will. And now we have a successful Cozmo. And every Cozmo, and we're talking in the hundreds of thousands here. I can't get into the exact numbers. But every Cozmo has to do this before it gets shipped out. We have to verify that. And so that comes at a significant cost. Another big one, probably not that surprising to people here. We don't control illumination, so dealing with a variety of illuminations, especially for marker detection, is a big challenge. One thing that got added late in the game for the product is that the cubes have little lights on them. And so now when you're trying to detect these markers in the dark, but with the lights on right next to them, it turns out doing any kind of local filtering for binarization is very challenging. There's not a lot of room around those markers, so that turned out to be kind of an interesting one that I didn't get to know about until much later in the game. And this one I won't spend too much time on again for time. Failure detection turns out to be just as important as getting things right. So it looks silly if Cozmo whiffs a cube and doesn't even know it. That's just stupid. So it doesn't look very alive. So we need to make Cozmo reactive and realize, oh, you move the cube and go over here and try again. And there you can see he does a little extra maneuver because he wasn't quite lined up. Here he's going to bump into the cube here. He realizes it. Now, in the full shipping version, he'll also make little noises and get frustrated and those kinds of things when he's making mistakes. But that makes, again, him seem not only more believable, but also more forgivable that he isn't perfect, because he's not. OK, I'm not going to read you this slide, but hopefully you've got a sense of what Cozmo is all about and what the challenges are in making a product like this. And in addition, that he's a fun little guy to develop for. So one of our engineers decided to tape a Post-it note to his face. And this was his sort of natural reaction. This wasn't programmed, which was kind of funny. And then finally, I guess got one video that I want to show. Independent of all the technology, this is really what we're trying to do. And again, getting back to education and impacting children, this is a really rewarding thing to see in our work. So these are play tests that we actually did in the office. So I feel like those are better than any commercial because they're actually real reactions from kids in playtests, which is pretty fun to see. So finally, I will end by saying we are hiring. I need help. So I would love to talk to anybody who's interested in working on this kind of thing, or if you know someone who's interested in working on this kind of thing. I'll be demoing Cozmo out at one of the booths. I don't remember the number, so come by and check them out. And I got 8 seconds left.
That was great. You're right. We see a lot of component technology. We work on the vision, or we work on the control system, or something like that. We rarely get to see the finished product, so it's really great to see.
Thanks.
And it's good to see the explanation of the issues that you had to face, which are not issues that we normally have to deal with.
Right.
Yes. So if anyone has any questions, we have a few minutes. Just step up to the microphone and address your question.
Yeah, thanks for a great presentation. For the Wi-Fi, since you have so many of the smarts on the phone, did you use a dedicated Wi-Fi connection? Do you use the house Wi-Fi connection? Do you have issues with reliability there?
So that was a very good question. It was a deliberate choice we made to actually make Cozmo the access point. So you put your Wi-Fi on him. That's because we have complete control over the network. Issue of resources and time to be able to support arbitrary, horrible network configurations people have in their home and trying to message all of that. It does come at a cost. It means that the user experience of working right out of the box is not as good and clean as we want it to be. It's actually much easier on Android because Android allows us to put you on the network from the app. iOS, if there's anyone here from Apple, if you would let us do that, it would be great. It's much harder to do that. So it's not the same. It's not really the connection flow we'd like to have, but for keeping the audio working and the video stream running and not having him appear to be broken the rest of the time, that was a decision we had to make.
On a related note, you've got a choice of networks. You could use Bluetooth.
Mm-hmm.
What was your decision process?
So interesting, the Overdrive is 100% Bluetooth. It's very low bandwidth, lots of great features of Bluetooth. We wanted to use that with Cozmo. Originally, that was the plan, to have all the vision on board and just do small commands over Bluetooth. The difficulty was streaming video. The bandwidth wasn't there.
Okay.
And the audio coming back, audio and face video coming back, so it's both ways.
Okay, if there are no more questions. Oh, we've got.
So my son got one of these for Christmas this year. Where are you going with Cozmo next? What are you going to add to it, and is there going to be a Cozmo 2?
I can't say a lot. Yes, there's stuff being added. There are, the good thing about being driven by an app is that you, as hopefully you've already noticed, you do get updates. So we focused a lot at the beginning of the year on under the hood stuff we needed to fix after getting the thing shipped. So there's a lot of tech debt. But there have been small releases about once a month, once every 6 weeks, and we're going to continue to keep that up. Add new games, add new features, add new functionality. There will be some new pretty interesting stuff coming over the summer and this fall as we release again this fall. And then next year there will be some even bigger stuff.
Does it have a microphone inside it? And do you plan to integrate it to systems like Amazon Echo and stuff so that you can talk directly to Echo from here?
Also a very good question. He does not have a microphone. We do have the phone's the device, the tablet or whatever. We can leverage that microphone. Right now he does not do voice recognition, nor is he integrated with Echo, but that is all I'll say about that.
Okay. Thank you.
All right. Thank you very much.
Thanks
once
very
again.
much.